All right, welcome to section 5.1, starting chapter 5 here, and we're going to first look at composition of functions, wanting to make sure that you really understand how two functions are composed. So this should be something that they covered in an intermediate algebra class. It's used often in calculus as we put functions together in order to just because they're working together, and so sometimes it's best to put them together and simplify. But we want to make sure that you understand the machine that's involved here as we go through and look at the composition of functions. And so what we want to make sure is that you understand just the basics. We'll remind you of them. You'll have two functions, f of x and g of x, right? Both will be functions. And the composition is sometimes, most of the time, written as f open circle g, which we read as f composed with g of x, right? And so what we want you to remember, or hopefully not, but teach you for the first time, is that this is f of g of x. That means we're taking the function f and evaluating it g of x. And there's two things that they're going to do. As with most books, they're going to make sure that you understand the basics of it from a numerical point of view. So whenever you're dealing with the numerical point of view, you want to just kind of feed the machine. You want to put it into the first function, which is always that second function listed, right? We first go into g of x and then apply f the way this is written. And so you'll want to first apply the number to g, see what g does to it, and then apply it to f. And so and then the other thing that they're going to ask you to do is do it in general. So I'll put a general algebraic. And you'll see both in the homework, and I have some examples from the homework right here. So one of the first examples in the homework could be the most confusing, but I don't think so. What it's going to tell you is it's going to say, well, here's x, and here's f of x, and g of x. And so they have this little grid, and we'll want to make sure that you understand the grid. So they'll have x is negative 3, x is negative 2, x is negative 1, x is 0, and then 1, 2, and 3. So I got this straight from the homework, and I like this little problem just for its illustrations. And then they're going to have a number here, 10. So what this means is this 10 right here, f of negative 3 is equal to 10 is what this grid is saying. That's what that 10 means. That if x is negative 3, its f value is 10. G of negative 3 is negative 4. So rather than list those all out individually, they're going to come in and fill in the grid. And we'll trace it really nicely. I can use highlighters and stuff. But just to help you understand this problem. So this section actually will go relatively quickly. So this is an 8. Let me just fill in some numbers here. Negative 1, a 6 and a 0, a 4 and a 1, a 2 and a 0 and a negative 1, and a negative 2 and 4. And so here's the things that they're going to ask you to do. So for example, they'll have number 1, part A. They're going to ask you to do f composed with g of 1. Okay, and I'll put it the way they have it. They have that in parentheses. No problem. This is just f of g of 1. That's what they want to make sure that you remember. So what's g of 1? Let's go find it. I'll highlight it in blue. Here's g is along the bottom row. G of 1 is 0. Right? So now we're going to come in here and we're looking for f of 0. So what's f of 0? No problem. I'll highlight this one in yellow. They want f to be 0, so I go here. That's this 1 right here. F of 0 is just plain old 1. And we just trace it through like that. Let me get rid of those highlights because we use this same grid for all of the problems. And so it should go really quickly if we understand. So the end answer, if it wasn't clear, is 1. F composed with g of 1 is 1. B. G composed with f of 2. Well, what's that? That's g of f of 1. So what's f of 2. Sorry, I forgot what we were doing. F of 2. So I'm going to go find f of 2. F of 2 is right here. It's this 0. Um, Let me back that off of there and use the highlighter. F of 2 is right here. That's what f of 2 is. It's 0. So what am I looking at? I'm looking at g of 0. Now what's g of 0? Well, I'll go to where the 0 is for the x and find out that it's 1. Right? That g of 0 is 1, which makes me realize that I got the wrong thing for f of 0. F of 0 wasn't 1, it was 4. That probably drove you crazy. You probably already crafted an email saying, Jensen, you messed up. I did look at the wrong thing, so we got to be careful in there. So what was g of 1? G of 1 was 0 in that first problem. F of 0 was 4. Okay, I went down to the g of 0. G of 0 is 1. Right, so it's kind of fortuitous that I did that. So remember, you can compose anything. So we can do f composed with f. F composed with f of 3 is f of 3. So what's f of 3? Well, let's go find f of 3. We'll highlight that in red. Here's f of 3. Where's f of 3? Right there, negative 2. So this is f of negative 2. And what's f of negative 2? Well, we see that right there in the top row. That's 8, and we're finished. So that's what the first kind of homework problem is going to feel like, and then they get into more traditional ones. So for your second example here in 5.1, we'll let f of x be 3x, g of x be 9x squared plus 7, and we're going to look at f composed with g of 4. Okay, no problem. What is this? Well, we know what that means. That's f of g of 4. So the first thing that we need to do is figure out what g of 4 is. Well, what's g of 4? Well, g of 4 is going to be, well, let's go find out. G of 4 is 9 times 4 squared plus 7, or 9 times 16 plus 7. So you're welcome to grab a calculator, and if we look at 9 times 16 plus 7, we get 151. Okay, so we get 151. So that's what g of 4 is. So this is all side work over here. This portion right here is side work to figure out what that number is. Now what's f of 151? F of 151 is 3 times 151. And if we take 3 times 151, we get the answer that they'll have as a correct answer, 453. Awesome. Right, there's our work involved there. That's part A. Okay, so notice that we didn't have to actually put the algebra together. We could just do the numbers. So what is here's another one, part B. Sorry, let me get a pen here. Part B. F composed with f of 1. Well, what's f composed with f of 1? That's f of 1. That's f of 3 times 1. That's f of 3. Well, what is that? That's 3 times 3, which is 9. And very quickly we can get that answer, right? And they'll just range through. It can get big, right? If they pick g, here's g composed with g of 0. Okay, so that's g of 0. No problem. That's g of, well, g of 0 is obviously 7, right? We can see that 9 times 0 plus 7 is 7. And now g of 7, no problem. 9 times 7 squared plus 7. 9 times 49 plus 7. And what's 9 times 49 plus 7? 448. And we just go through the arithmetic like that. Now, what's the point? The point is to make sure you understand composite functions. So notice that we would run into a problem. I'm just going to try to foreshadow some things. If 4 didn't work in the g function, I couldn't do this. Even if 4 could work for the f function, it goes through g first. We always got to respect through that. So we'll be talking about domains and things like that as we move forward. Now, what's going to happen, and it's actually here, I guess, we'll have to start to pay attention to it. As I do my third example, they're going to have f of x is equal to 9x plus 3. g of x is equal to x squared. And so what they're going to ask us to do is find f of g, not of a number, but of x. So we got to get this out individually. And so what they want is an algebraic simplification. So we know what this is. This is f composed with g of x. Now we know what g of x is. It's given to us. That's f of x squared. And what do I do with x squared? I put it in everywhere I see an x. So I get a 9. And I see an x next, so I'm going to replace the x. And I'll highlight that. I'm going to replace the x with x squared plus 3. And so f composed with g of x is 9x squared plus 3. Now they're going to want to know the domain. And so the way we figure out the domain is we consider the domain of g of x first, that very first function. It was all reals. And then we look at the composite. Could the composite still handle all reals? The answer is yes. So the domain is still negative infinity to infinity for f composed with g of x, the way we have it written here. And it could be the other way. It could be g composed with f of x, right? And they may do g composed with g and all of that. We don't care. We'll just take it one thing at a time. No problem. Will this be different? Drastically different. If you think they're the same thing, just keep watching. And also reflect back to your algebra days. What's f of x? Well, we know f of x is plus 3. 9x plus 3. And so what's g of 9x plus 3? Well, it would go into the g function, and everywhere I saw an x, I would replace it with 9x plus 3. So let's do that again in red. We have 9x plus 3, and what g is asking us to do to anything in that parenthesis is square it. So it's drastically different. It's 81x squared plus, what's 3 times 9? 27. 54x's plus 9. That's what we're looking at. Way different than 9x squared plus 3. What's the domain? Still, the domain is any restrictions for f of x? No. I can multiply anything by 9 and add 3. Any restrictions for 81x squared plus 54x plus 9? Nope. So the domain's still negative infinity to infinity. Now, when would you have domain restrictions? Of course, you know, whenever you have rational functions or square roots involved, those are where our domain restrictions come in. And so another problem that you'll see along the way is something like this. F of x is equal to x minus 9. G of x is equal to 5 over x. And what are they going to ask us to do? Not earth-shattering, right? You already know. F composed with g of x. Easy. We've been writing it the whole time. F of g of x. So what's g of x? G of x is 5 over x. Awesome. And so what are we going to do with the 5 over x? Everywhere we see an x and f of x, we're going to put it in. So what do I have? I have 8 all over 5 over x. Let me keep with consistent patterns and put the substitution in red. Because what you should see in black is the f function with its x replaced, the red part replaced with the g function 5 over x. Now we need to simplify. So as we simplify, the easiest way I know to simplify is to clear the denominator of x, right? Get rid of the complex fraction. So everything's going to be multiplied by x. So I'm going to multiply 8 by x, 5 by x, and 5 over x by x, and 9 by x. So hopefully that's making sense to you. I need to get rid of that denominator here. Good, just did. And what am I left with? I'm left with 8x over 5 minus 9x. So that's what f composed with g of x ultimately simplifies down to be. And it's very simple, right? Where are we? Algebra 1, simplifying a complex expression. Algebra 2, simplifying a complex expression. Right? That's what we said that we were good at as we moved into here, or that we could quickly get reminded. So let's talk about the domain. Now, the domain always takes into account two things in a composite function. And I said it in the previous ones, and you can back it up and make sure I did. And I know I did. The first thing it does is it recognizes the initial function, g of x. Right? So I underlined it there. I don't know if that stood out. We consider this g of x first. because that's what has to happen first. Is there any domain restriction to g of x? Would I have any problems? I would absolutely have a problem. Now, not everywhere. I just couldn't let x be 0. If we ever had to do f composed with g of 0, we would have serious issues, because the first thing that would have to happen, and that's why they're having you do it with the numbers, is g of 0, which does not exist. And so we cannot plug in 0. Then the other second thing to look at is the end function. Is there any domain restriction, any additional domain restriction to the composite that came out? Now notice in the composite, 0 is not a problem. So the only way you're going to pick up 0 is to consider that first g of x function. So you see the other one there, at least I hope so, that there's no way you can let x be equal to 5/9. If you let it be equal to 5/9, we got a 0 underneath there and some problems. And so that's what we have. Any x you want, but not 0, I apologize, and not 5/9. Let me put an x through that equal sign. That nice. Let's look at g composed with f of x. I'll try to bring this down a little bit. We know what that is. That's g composed with f of x, or g of f of x. We know that f of x is 8 over x minus 9. And what do we know? We know that this 8 over x minus 9 needs to go into the f function. Or sorry, the g function. Said that wrong. So what's that? That's 5 over, and then I'll put it in red just to keep some consistency, exactly what's in the parentheses. 8 over x minus 9. That's what a function's always done. Take what's in the parentheses and put it in for x. Okay, what we have here is a easily simplified complex fraction. We have 5 over 8 over x minus 9. We know how to handle that. This is the same as 5 divided by 8 over x minus 9, or 5 times x minus 9 over 8, or 5 times x minus 9 all over 8. Okay. I don't know, you can distribute that 5, but that's what g of f of x is. Notice completely different. Now, any domain restrictions for the original function f of x? Well, let's take a look. Yeah, we can't let it be 9. So the domain is a set of all x such that x definitely doesn't equal 9. Is there anything else? Let's look at the composite. Does the composite have any points where it can be undefined? The answer is no. So there's only one domain restriction. We cannot let x be 9, otherwise we'll have an initial problem with f if we try to plug 9 in. We always respect that original domain restriction. So hopefully this is a nice reminder of the composite functions that you looked at back in Algebra 2. They would have needed to be talked about right before talking about logs and exponentials. So I know it was there, but how fresh it is, we don't know, and that's why we talk about it again. How important is it? Super important, right? As you move forward, this is pre-calculus, so as you move forward into calculus, it will be very important that you understand composite functions. They'll be an integral part of what you do. All right, enjoy.